We know that the main stationary electrical component of a DC motor is the frame to which the main field assembly is attached. This field assembly is composed of the so-called poles, which are formed of stamped laminations securely bolted to the frame. These field poles are wound with wire to form the field coils. These coils are the ones that form the fields represented in the series DC motor, the shunt DC motor, and in the compound DC motor. As can be seen in these diagrams, the field windings are shown stationary. The field poles attached to the frame are accompanied by interpoles which are positioned between the field poles and are made up of a pole piece and a coil. These interpoles form an essential part of the field by providing reduction or elimination of sparking due to induced voltages created by the armature current flowing through the armature coils. The main rotating component of the DC motor is the armature, which holds the shaft of the motor and a cooling fan. The armature coil is formed by laminated slots which have been wound through the slots. The ends of the coils in the armature are connected to what's known as the commutator. The commutator is made up of many separate bars or segments which are separated by insulators. Each of these bars are connected to the armature coils. The commutator is perhaps the most critical single part of a DC motor. Its design and manufacture must ensure a perfectly round, concentric, and heat-stable surface for the brushes to ride on. The brushes are small blocks of special carbon that function as the interface between the external power source and the commutator. These brushes are mounted in brush holders made of brass with a stainless steel brush finger under spring tension. This spring is designed to give constant pressure throughout the life of a brush, regardless of wear. The brush must be properly seated in the holder and pressed firmly against the commutator. This brush holder must have a clearance of about 1/16 of an inch between the commutator surface touching the brush. Too much space due to an inclination of the holder will cause the brush tip to break. If it is too close, it will also cause it to chatter and burn. If the brush becomes broken, there will not be a good contact between the commutator and the brush, and it will show up as an open circuit condition. A motor will have an even number of brushes, half of them connected to a positive terminal and the other half to the negative. In general, the number of brushes in a motor equals the number of field poles. These brushes wear out with use and need to be replaced once they reach a certain wear mark which is located on the brush. When a new set of brushes is installed, it is important that the brushes be properly seated to fit on the commutator. The brush's wear should be checked periodically during the preventive maintenance. The brush assembly is mounted on the rear end plate for easy reach, where an access hole or opening is provided for motor inspection and for adjustment of the brushes and holders.